Hello, my friend. My today video is about motivation of using deep reinforcement learning, and our case study is autonomous vehicle. I should say that the content of this video is also applicable to the other case studies such as healthcare, marketing, and computer vision. Okay. Here you see the list of the outline. We start by an introduction to deep reinforcement learning, highlighting its application, and then we list and discuss 8 motivation of using deep reinforcement learning in the context of autonomous vehicle. Okay, deep reinforcement learning. Deep reinforcement learning, abbreviated as DRL, is a major branch of machine learning where an agent learns to behave in an environment by performing action and observing the associated result. Okay, we have an agent interact with the environment, observing the result and performing action. Okay, DRL can be applied to solve Markov decision process with unknown transition probability. In a DRL process, an agent observes its current state, an agent receives its current state, then take action, and based on the action, it receives immediate cost and new state. Okay, agent take action, then receive immediate cost and new state. The observed information, immediate cost, and new state is used to adjust the agent policy. Based on the immediate cost, we conduct optimization and we adjust the agent policy. This process repeat until the agent policy approach the optimal policy. We repeat this process until we reach to the optimal policy. Let me summarize. We have agent take action based on its current state, receive a cost function and new state. Based on this information, conduct optimization, adjust the policy, and repeat this process until we achieve to the optimal policy. Okay, what are the application of deep reinforcement learning? DRL can be used in financial services, marketing, healthcare, robotic, computer vision, and autonomous vehicle. In this video, we elaborate on the motivation for using deep reinforcement learning in autonomous vehicle. Okay, this video is a valuable resource for PhD student and researcher interested in applying DRL to AV. Not only the autonomous vehicle, but also we can apply this motivation to other domains such as financial service, marketing, healthcare, robotic, and computer vision. But our case study for this video is autonomous vehicle, and we provide a comprehensive overview of the motivation and benefit of deep reinforcement learning for autonomous vehicle. Okay, what is the first motivation? Deep reinforcement learning can optimize large state and action space. Okay, in autonomous vehicle, we have large state and action space. For example, or state space comprise the position, velocity, and or action space comprise moving direction, speed, and communication parameter. For example, we have infinite point, infinite position, and we have a very large state and action space, and we have to use deep reinforcement learning to handle such a scenario. Okay, for instance, in autonomous driving or UAV communication, DRL can optimize each vehicle trajectory. DRL can be used to optimize the vehicle trajectory, and this trajectory shape a very large state and action space. Okay, we can use policy-based deep reinforcement learning, such as proximal policy optimization, to approximate policy over a high dimensional state. Okay. The second motivation is DRL is low cost in implementation and inference. What do we mean by inference and inference time? In deep reinforcement learning, inference time is the amount of time it takes for a DRL model to process new data and make a prediction. Okay, the amount of time it takes for a DRL model to process new data and make a prediction. Okay, DRL model can be trained online or offline. Once the model is trained, it can be used to make prediction on new data very quick. Okay, once we train the model, we can deploy the model in real time and make prediction on new data very quickly. Most deep reinforcement learning model can process new data in just a few milliseconds. And as far as I know, when we are using deep learning, we can make a prediction in less than 1 millisecond even. This make them well suited for using real-time applications such as collision avoidance and object detection. Okay. For example, we here in the second paragraph we have an example. This is particularly beneficial for UAV with limited onboard processing capability. As you know, in UAV we have SWAP constraint, size, weight, and power constraint, and UAV have limited onboard processing capability. For example, a trained deep reinforcement learning model for collision avoidance. We train a deep reinforcement model for collision avoidance can be deployed on UAV to make real-time decision. Okay, we can train a deep reinforcement learning model for collision avoidance, then deploy on UAV to make real-time decision using lightweight computation, and thus we facilitate swap requirement. Okay, the third motivation and is that DRL has a long-term goal. This is what distinguish deep reinforcement learning from optimal control theory. The goal of a DRL agent is to learn a policy that maximizes the expected cumulative reward. Indeed, this is very important sentence. DRL is the discipline that has been trying to build long-term planning capability in autonomous vehicles. DRL is the discipline that has been trying to build long-term planning capability in autonomous vehicle. DRL algorithm enable autonomous vehicle to account for future reward. Okay, for instance, in path optimization, deep reinforcement learning can ensure that autonomous vehicles plan their routes to minimize total travel time. Okay, can ensure that autonomous vehicle plan their routes to minimize total travel time rather than optimizing for individual short-term paths. Okay, this deep reinforcement learning enable autonomous vehicle. We have a long-term goal, or long-term goal is minimizing travel time, and we don't just pay attention to the short path. Okay, DRL is adaptive. Okay, adaptability means the DRL agent can adjust its behavior based on change in the environment. I think this is clear. In other words, DRL algorithm can continuously learn and adapt to changing environment by updating their policy based on new experience. Okay, DRL algorithm can continuously learn and adapt to the changing environment by updating their policy based on new experience. For example, consider a UAV assisted sensor network. We have multiple UAV are flying and multiple ground sensor. Okay, please consider the task of data collection and scheduling. The status of the ground sensor data, battery, queue length, channel is changing over time, and the UAV learn a DRL policy to adjust to this change and to update based on this change. Okay, DRL can be model free. I think all of you know that we can have model-based deep reinforcement learning. We can have model-free deep reinforcement learning. But this is a very critical advantage for deep reinforcement learning that can be model-free. It doesn't require a mathematical model of the environment. In the scenario such as autonomous vehicle, it is difficult to characterize the environment and make a model, and therefore we have to use deep reinforcement learning, which is adaptive and model free and doesn't need any model from the environment. Okay, DRL work with outdated data. Uh, Deep reinforcement learning algorithm, we use them when we don't have a real-time knowledge. When we have a real-time data, when we have a real-time knowledge, we can solve our problem using other mathematical approach. But when we have outdated data, we can use deep reinforcement learning. For example, imagine again UAV assisted sensor network. This UAV doesn't have real-time knowledge from ground sensor data. Instead, UAV pull the ground sensor individually to retrieve data from them. UAV is working with outdated knowledge. This is very important. Okay, DRL can reduce signaling overhead in contrast to centralized optimization that we have a large volume of signaling overhead when, for example, multiple autonomous vehicles are using deep reinforcement learning, they can individually do their optimization, and this reduce the signaling between this autonomous vehicle and reduce the communication between them. Therefore, when we use deep reinforcement learning, we can have independent agent that separately do optimization, and this reduce signaling overhead and communication. Okay, DRL scale to optimize many factors jointly. Deep reinforcement learning algorithms are capable of handling multi-objective optimization, which is critical in complex AV environment. In AV environment, usually we have multiple objectives that we want to balance and optimize them, and therefore we need to use multi-objective deep reinforcement learning to handle the scenario. Okay, this allow autonomous vehicle to make decisions that balance various objectives such as energy efficiency, communication quality, and coverage. Okay, this is my reference, article published by me on Medium. Please check this article to gain better knowledge, and thank you very much for watching this video. If you learned something from this video, I appreciate to like and subscribe. Thank you.